Good morning children. Welcome to today's math class. Today we shall learn about square root of numbers. Today's topic is finding square root. Finding square root is the inverse operation of squaring. Square root is the inverse operation of square. Okay. Now listen. What is the square of 2? 2 square equal to 2 times 2. That is 2 into 2 equal to 4. Then what is the square root of 4? Yes, it is the inverse operation of square. So square root of 4 equal to 2. From the pair, we can take one number, that is square root. Square root of 4 equal to 2. Then what is the square of 9? 9 square is what? 9 square equal to 9 into 9, which is equal to 81. Then what is the square root of 81? Square root of 81 equal to 9. Isn't it? Okay. Then what about the square of minus 9? Minus 9 square. What is the square of minus 9? Yes. It is 2 times minus 9. 9 minus 9 into minus 9, which is equal to 9 into 9, 81. Minus 9 into minus 9. 2 negative 9s equal to plus 81. Isn't it? Yes. Then what is the square root of this 81? Square root of this 81 equal to minus 9. Isn't it? Here we are multiplying 2 negative 9s. So square root of 81 equal to negative 9. So we can say that square roots of 81 are plus 9 and minus 9. So there are two integral square roots of a perfect square number. There are two integral square roots of a perfect square number. But in this chapter, we shall take up only the positive square root of a natural number. Okay. The positive square root of a number is denoted by the symbol. Yes, this is the symbol for square root. Okay. Now, what is the square root of 36? 36, square root of 36 equal to 6. Square root of 49 equal to 7. Okay. Yes. Now, there are three methods for finding the square root of a number. Three methods. Three different methods. They are repeated subtraction method, prime factorization method and long division method. Okay. In this chapter, we mainly focused the two important methods, that is prime factorization method and long division method. Okay. Anyway, I just tell the repeated subtraction method. In repeated subtraction method, we use one of the property of the square numbers. That is, every square number can be expressed as the sum of successive odd numbers starting from 1. Every square number can be expressed as the sum of successive odd numbers starting from 1. That is 1 plus 3. What is the square of that number 1 plus 3? 2 numbers. 2 odd numbers. Their square is 4. Then 1 plus 3 plus 5. 3 odd numbers. Sum of their sum equal to 9. 3 square is 9. Like that. That is one of the property that we learned. Okay. So we use that property in repeated subtraction method. So here we will subtract the odd, successively subtract the odd numbers from the given number. Okay, I will show you one example. 9. 9 is the number. Find the square root of 9 using repeated subtraction method. So, in this method, first we subtract first odd number from 9. So 9 minus 1 equal to 9 minus 1, 8. First subtraction, first odd number. Then next odd number. Subtract next odd number from that number, 8. It is 5. Then next odd number, 5. So 5 minus 5, 0. Okay, so this is repeated subtraction. Subtract successively the odd numbers from the given number till we will get a 0 difference. Okay, now how many times we subtracted? 3 times. So that is the square root. So square root of 9 equal to 3. Okay, clear? Okay, that is repeated subtraction. Anyway, it will be time consuming. If it is a 3-digit number, 4-digit number, it will be time consuming. That's why we leave that method. We follow the other two methods. That is prime factorization method and long division method. Okay, what is prime factorization? Actually, prime factorization means division, but not in the normal division. It is the division, downward division. Using the smaller prime numbers as divisors. Here we choose the divisors as the smaller prime numbers. Okay, let me show you one example. What is prime factorization? Oh, okay, before starting prime factorization, let me ask one question. Do you remember the divisibility rule? Divisibility of 1, sorry, not 1, 2. Divisibility rule of 2, 3, 4, 5, 9, etc. Do you remember it? Yes. How will you choose the divisor? That is, what is the divisibility rule of 2? Yes. The number ends with an even number. The dividend is ends with an even number. The number is divisible by 2. Okay. Then, what is the divisibility rule of 3? If the number ends in 3, it is divisible by 3? No, never. Divisibility rule of 3 is sum of the digits. Sum of the digit is a multiple of 3, then it is divisible by 3. Just add the numbers. The sum is a multiple of 3, then it is divisible by 3. That is divisibility of 3. Divisibility rule of 3. Then, what is the divisibility rule of 5? Yes, it is very simple. If the number ends with 0 or 5, is divisible by 5. Isn't it? What is the divisibility rule of 4? 4. Yes, the last 2 digits is a multiple of 4 or it is divisible by 4, is divisible by 4. The last 2 digit is a multiple of 4 or it is divisible by 4, then the whole number is divisible by 4. That is divisibility rule of 4. Then 9. 9 same as 3. Yes, sum of the digits is a multiple of 3 or 9, then it is divisible by 9. That is the divisibility rule. Okay. Then I will show you one example. Prime factorization. Find the square root of the number 324 using prime factorization method. Find the square root of the number 324 using prime factorization method. Okay, so prime factorization means downward division. Okay, so choose the divisor, first divisor. I told you choose smaller prime numbers as the divisors. Okay, so here the number ends with 4. So it is an even number. So the number is divisible by 2. 2 is the smallest prime number. Okay, 2. Then divide. First number 3. How many 2's are in 3? Only 1 2. So write here that 1. Quotient 1. So 1 2 is there. Then 1 is balanced there. Okay, 1 2s are 2. Therefore, 1 is balance. That one will give to the next number, nearest number. So, here, the second number is 2 and we carry 1 to that number. So, it becomes 12. So, the number becomes 12. Okay. Then in 12, how many 2s are there? Yes, in 12 there are 6 2s. So, 6 into 2, 12. Then last digit. 4 divided by 2, that is 2 2s are 4. Okay. Then again, continue the division. Again, the last number is an even number. So, it is divisible by 2 itself. Okay. So, 2. It is not divisible by 1. So, we can take the first two numbers, 16. In 16, how many 2s are there? 8. 8 2s are 16. And in 2, only 1 2s. Now, look at the number. Is it divisible by 2? No. The number ends with 1. So, the divisibility rule. It is not divisible by 5. Okay. So, just check the sum. Find the sum of the digits. So, 8 plus 1 is 9. So, it is divisible by either 9 or 3. So, we can select the smaller number first. We can choose. So, 3. First choose 3 first. So, in 88, how many 3s are there? 3 3s are 9. So, it is not possible. So, 3 2s are 6. 6. And 2 is balanced there. Okay, just subtract. So, 2 remains there. So, 21. So, the next number becomes 21. In 21, how many 3s are there? 7. 7 3s are 21. Okay. Again, continue the division in 27. Which is the divisor here? Yes, 27. 7 plus 2, 9. So, it is also divisible by 3. So, 9 3s are 27. Again, 9 is divisible by 3 itself. So, 3 3s are 9. So, these are the prime factors of 324. Okay. These are the prime factors of 324. Okay. By pairing the prime factors, we can write this as 324 equal to, just pair the factors. First 2. 2 into 2. 2 2s are there. The next 3 into 3. Just pair the factors. Pairing the factors. 3 into 3. Then last one more pair. 3 into 3. So total 3 pairs are there. Okay. So square root of 324 equal to, from each pair take one number and multiply. That is the square root. From each pair take one number and multiply. That is square root of 324 equal to, from first pair we take 1 2. Then the next pair 3 into 3 take 1 3. And the last pair 1 3. So what is the product? 2 into 3 6. 6 into 3 18. So 18 is the square root of 324. This is prime factorization method. Just find the factors first using division method, downward division method. Okay, so remember that choose the smaller prime numbers as divisors. Then write the factors as pairs. Now from each pair take one number and multiply. That will give you the square root. Now clear? This is prime factorization method. Okay. Can you find the square root of one number? The next number? Okay, let's do. The next number is 256. Okay. 256. 256. Find the square root of 256 using prime factorization method. The same way. 256. Okay. First number divisor is 2 because the number ends in 6. So it is divisible by 2. Into 1 2 is there. And in 5 there are 2 2s are 4. Then one balance is there. That balance gives to the next number. So the number becomes not 7, it is 16. So in 16, there are 8 2s. Again, divide. The number ends in an even number. So it is divisible by 2. Then first number is not divisible by 2. Therefore, take the first two numbers. First two digits. So 12. In 12, there are 6 2s are there. And in 8, there are 4 2s. Okay, clear? Again, an even number. It is divisible by 2. So in 6, there are 3 2s. And in 4, there are 2 4s. Okay, same way, continue the division. Again, even number, 2 is divisible. So in 3, there are 1, 2. And balance 1 is there, 12. And in 12, 6 2s are there. Again, 16 is divisible by 2. 8 2s are 16. 8 is divisible by 2. 4 2s are 8. Again, 4 is divisible by 2. 2 2s are 4. So these are the prime factors of 256. Okay, let's arrange the prime factors as pairs. Okay, how many pairs are there? 1, 2, 3, 4. 4 pairs are there. Okay, 2 into 2, first pair. And next second 2 into 2. Then third 2 into 2 and 2 into 2. So 4 pairs are there. So from each pair, take one number and multiply. That will give you the square root of 256. Okay, clear? So what is the square root? 2 into 2 into 2 into 2. From each pair. So 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. So 16 is the square root of 256. Square root of 256 equal to 16. Okay, this is prime factorization method. Okay, clear? Okay. Can you find the square root of 48 in this method? Okay, just find the factors of 48, prime factors of 48. Okay, let us check. Is 48 is a perfect square or not? Okay, first find the prime factors of 48. So 48 is divisible by 2 because 8 is ends in 8, even number. So in 2, 4 2s are 8. Again even number, divisible by 2. 1 2s are 2 2s are 12. It is divisible by 2. 6 2s are. 6 is divisible by 2. 3. Now look at the prime factors. Okay, we can write like this. 48 equal to 2 into 2 into 2 into 2 and last one number without having a pair. 3. 3 has no pair. So 2 2. First 2 pair. Then 3 has no pair number. Then is this 48 a perfect square? No, 48 is not a perfect square because 3 has no pair. Okay, so can you make this 48 a perfect square number? How does 48 become a square number? Yes, we need, if we get a 3, the number become a perfect square. Clear? 3 is the only factor which does not have a pair number. Okay, so when we multiply this 3 with this number, we will get a perfect square. Just multiply 3. We need to multiply 3 with this 48. Just multiply 48 into 3 is the next perfect square number. 48 is not a perfect square because the prime factors of 3 does not has a pair. So the next perfect square is 48 into 3. When we multiply the number with 3, we will get the next square number. So the prime factors become, yes, 2 into 2, 2 into 2 and 3 into 3. We multiply 3 with 3. So these are the prime factors. All numbers having pairs. So what is the number? What is the perfect square number? 48 into 3 48 into 3 equal to 144. 48 into 3 is 144. And what is the square root of 144? No need to find it is again. Already we have the prime factors. So it is easy to find the square root of the new number 144. The same factors, but 3 is added there. Okay. So what is the square root of this new number? 144 equal to 2 into 3. So what is the square root? 12. Square root of 144 equal to 12. 2 2s are 4. 4 into 3, 12. Okay. So this way we can check whether the number is a perfect square or not. If the prime factors does not have a pair, shows the number is not a perfect square. And we can change. We can change the number to a perfect square by multiplying that number with the given pair, given number. Okay. This way we can divide the number and find the square number before the square number. Here we found the square, next square number by multiplying with 3. The same way we can divide the number 48 by 3. We will get the before square number. Okay, 48 is not a square number. Before that number 48, there is a square number. We can find that by dividing the number by 3. If we multiply with 3, we will get the next square number. Divided by 3, we will get the before square number. Okay, clear? Okay, I will show you one example. Okay, look at the example. Find the smallest number by which 9408 must be divided so that the quotient is a perfect square. Find the square root of the quotient also. Find the smallest number by which 9408 must be divided so that the quotient is the perfect square. Okay. So in this type of question, first find the prime factors. Okay. So 9408. The prime factors of 9408 is 2 into 2 into 2. There are 3 pairs of 2. 2 into 2, 2 into 2, 2 into 2. Okay. Can you do the prime factorization? Okay, just go through it. It's very easy to find the prime factors. The number is divisible by 2. Okay. And one other factor, 7 into 7 and 1 3 is there. So these are the prime factors of 9408. Here 3 has no pair. 3 has no pair. So if we divide by 3, we will get a new number. Okay, the smallest number must be divided as 3. Find the smallest number by which 9408 must be divided. So the smallest number divided is 9408 is 3. Okay, because 3 has no pair. So you have to divide the number 9408 divided by 3. Normal division, not prime factorization. Just divide the number by 3. So what is the quotient? Just divide this number by 3. 3 3s are 9. 0. Next number 4. In 4, 1 3s are 3. Okay. Then subtract 1 balance. Next is 0 brings down. In 10, there are 3 9s are 3 3s are 9. Again subtraction. 1 reminder. Then brings down 8. So 18. In 18, 6 3s are 18. So 0. So just divide the number by without having pair number. So the new number is, that is the quotient is 3136. 3136 is the new number. By just divide by 3. Then what is the square root of this number? Yes, already we got the factors. Prime factors of 9408. In that pair, 1 3 is there without having pair. 3 does not have a pair. So just avoid that 3. Okay. The remaining factors is the square root. Clear? So what are the numbers there? Okay. Here are the numbers. 3 pairs of 2 and 1 pair of 7. 3 pair of 2 and 1 pair of 7. These are the factors. Okay, let's do the prime factors. You will get the factors. Okay, so what is the square root of this number? Here, no need to find again the prime factors. Already we got the prime factors of 9408. In that factors, 3 is the only factor. Does not have a pair. So just leave that 3. That means we divide the number by 3. Also, just leave that 3 from the prime factors. Okay. The remaining numbers is the square root. So, what is the square root of this number? There are 2 into 2. 3 pairs of 2's are there. 2, 2, 2. 3 pairs. From that, we can take, from that factors, pairs, we can take 2 into 2 into 2. And 1 7 is there. 1 pair of 7 is there. So, take 1 7. Now, find the product. That is the square root of the new quotient. 3136 is the quotient by dividing it with 3. Okay. So, square root of this number is, what is the square root? 2 into 2, 4. 4 into 2, 8. 8 into 7, 8 into 7, 56. So, 56 is the square root of the new number. That is the quotient. Sorry, here no. 3136. Square root of this number is 56. Clear? This way you can find the number. Okay, clear? Okay, that's all today's class. We will discuss the same topic in the online class. Okay, anyway, you have to write these 2 questions in your notebook. Okay, thank you. Have a nice day.